Really just want to talk a little bit about a project that we've done over the last 12 months working with a startup business who had a legacy piece of software that was an installable, downloadable, kind of buy a CD-ROM type piece of software, and how we've worked with them and Windows Azure to transition that software from a buy a CD type business model to a software as a service business model. And specifically about some of the challenges and the thought processes that they've gone through and we've helped them through in terms of actually how do we design an application to go from that old, slightly disconnected world to a much more social, integrated, available anywhere, available anytime world. And some of that involves kind of looking back at some of the context of it, some of the changes and shifts that happen in computing, and some of that is around some of the technical things that you have to think a little bit differently about. So in order to walk through some of the presentations, I'm going to introduce myself. I'm Matt Quinn, MD of a small Azure consultancy called IQCloud Consulting. We specialize in helping customers design and build solutions for Azure, often working with ISVs who have their own developers or doing a full build and deploy for clients who don't. So we specialize on Azure. Almost everything we do ends up being Azure integrated to a greater or lesser extent. And we've been working with Azure since it was called Red Dog, which there are a few little hang-ups of that lying around in the platform since 2009. DrillBoard, the client we're talking about, we actually, with them, won Cloud World Forum Award for Best Enterprise Case Study. Not quite sure how it fits into the enterprise category, but somehow we managed to get it into that. The video case study was obviously quite good. It was with the Welsh FA, so I guess maybe they qualify as an FA. They're using the software that we've developed on Windows Azure. Like I said, they're a startup with a traditional business. It was a piece of technology that the client had licensed, kind of one-man band, developed it in Norway, and they'd licensed the technology with a view to kind of taking it out to the masses. What we've helped them do over the last 12 months is move that to that software as a service model, underpinned by Azure, and actually working quite closely with some really good support from Microsoft, things like the video case study and some of the business teams. The Microsoft internal football team have helped us review how the platform actually works and what it does from a coaching perspective, so it's been quite an interesting challenge. And over the last 12 months, there's a Silverlight version of the app so that it works on a Mac or a PC, it works in the browser, it can be installed to work offline. There's a Windows 8 app, which is in development, and an iPad app to follow, both of which fit the nice kind of model for a very visual training tool like DrillBoard and that touch kind of mentality. So I have a presentation that I'm going to try and jump to now. And effectively, what we've done is summed up some of the journey. Oh, mouse is doing something strange. Summed up some of the journey about how we thought about the cloud computing challenges and the way that computing was changing and how that's going to facilitate things that we wanted to do with Azure. So a lot of the analogies of what cloud computing is doing are very similar to what happened with the Industrial Revolution. Electrical power generation used to be sat in a factory. There was very expensive bits of kit that when it went wrong, expensive engineers turned up and tried to fix it, and it was running in the basement of your building. You had to maintain that knowledge of how to keep that piece of kit running or your factory shut down. When electricity generation got centralized into power stations, that completely transformed the way that factories operated as part of the Industrial Revolution. And that's now happening with compute. That compute power is being centralized and provided as a service in the same way electricity was over the grid. But it wasn't just enabling technologies that caused the transformation in the Industrial Revolution. It was social transformation as well. People were demanding to consume products in a way that traditional manufacturing didn't really support. And we're seeing the same thing with the social integration of applications and software, that people want to consume them whenever and however they want. They've got mobile phones, they've got internet wherever the hell they are, they've got their desktops, they're maybe pitch side if they're training, they're in the office. The whole revolution of integrating things socially changes the demands that are put onto an IT infrastructure, and that creates that unprecedented demand for availability and scalability within software. So that kind of revolution is putting huge demand on IT, and the cloud is a really handy way to solve that. The other thing that it does is it represents an opportunity for small players to challenge the established players. what we're seeing is startups who've got a bit of an idea, maybe a little bit of venture capital to get things going, can build an app without blowing wads of capex on building out infrastructure, and actually they can challenge the established players in the market. And you can move development of products really, really quickly, and it's seeing a real shift in markets and a real quick evolution of products, services, and the technology that underpin them, as seen with Azure evolving at a rate of knots. So for big enterprises, it's a kind of a survive or thrive moment. You know, you can just stick with the old ways, and maybe you'll make it through, and you'll kind of come out the other end with some shareholders and some business value. But actually, if you look back as an established business, or if you're a startup, you can take this opportunity to use these technologies to actually really change the game and really thrive. So that was kind of some of the scene setting of what we looked at with DrillBoard, and how they wanted to approach the market, and how they went out to get funding. You know, they wanted to set the scene for their funders to say, this is what we're after. So part of that transition was this disconnected piece of software, and how do we make that a really social app? How do we make that something that enables people to create soccer training activities, to share that with other people, coaches, teams, to share best practices within the game, to enable the knowledge at the top of the game to filter down to grassroots football players and coaches who do Sunday leagues and their local football club, and enable that to happen. And obviously integration with social sites such as Facebook and Twitter is kind of the obvious component of that, but actually enabling social in other ways is important. And social isn't just about Facebook, and it's about Twitter. If you think about the social gaming phenomenon of Zynga raising about $1 billion in an IPO, continuing to buy out those games, it's now big business. We're seeing more and more social software where people are recognizing from a retail perspective that people like to talk about themselves. It's a basic human instinct that we want to big ourselves up. And if you look at Twitter and Facebook and all the channels that are out there, people are shouting about what I'm doing. And you have to wonder actually who's listening. So a lot of it is about actually making the content relevant to people and sharing it in a way that people can consume, and tapping into that basic human need of talking about yourself. So this aspect, which is now moving across all sorts of aspects, so even business financing, one of the greyest, dullest areas of the world as far as I'm concerned, has infected this social world, or been infected by the social world, with social aspects enabling the funding of projects. So the whole world is tapping into this social phenomenon to greater or lesser degrees, and there's lots of commentation about, you know, is it a good thing or not? But actually, what does a piece of social software need under the hood? How does Azure help us meet those needs? How do we grow an application from this organic starting point to hopefully, you know, a huge scale system with tens of thousands, if not millions of users? Perhaps not 15 petabytes of data a year, but hopefully plenty of users. So the key piece is agility, the ability to move quickly, to adapt, to be a bit flexible, to do things with minimal cost up front, to do things in a kind of bootstrapped way. If we are going to build this system, if we can reduce the amount of cost and risk in doing that, we can be more innovative. We can try 3 or 4 projects with lower capital investment, and if 2 or 3 of them fail, let them fail fast, but actually 1 or 2 gems of ideas will come out of that and enable them to grow. And that agility and using the platform to facilitate trying something out, taking a product, even if it's internal at a company, bringing it out to market, demonstrating how it might work, and then internally looking for funding or looking for venture capital. It means you can be that bit more agile. It needs to be available. You know, how do we make this application reliable? Consumers are very fickle. If a system's down for a few minutes, they tend to not come back, particularly in a retail context. If they abandon that basket, they'll go somewhere else. How do we make it reliable? How do we make it scale? How do we make it available to everyone, everywhere? How do we make people want to use it? It has to be engaging. It has to be visually rich. It has to incorporate video and audio and integrate with their other social aspects of their lives. And doing so can involve storing more data, delivering it in different ways, and integrating it into third-party systems. So if we want to surface that content, third-party systems like Facebook will have to have a certain level of performance contract. If you post something on Facebook, Facebook expects your site to respond with a thumbnail image of that and some content and some metadata in a very timely fashion. If your site's down, Facebook will start dropping that content and your posts will be lost. So integration and delivering of those facilities sat with Azure underneath is a key way of really meeting those needs from day one. So the agility component, we have a platform as a service. We remove the need to micromanage the infrastructure. We're not caring about switches or configuring load balancers. We don't care about what kind of server infrastructure it's running on, how many processors it has. We can think as programmers, as developers, about the services we need to consume and then just consume them on demand. If the system needs new servers brought online because we're seeing spikes in demand, you can do that in minutes, not days, or as some enterprise companies we've worked with have moved an application to Azure because their internal IT department have said we need 6 months to bring a new server online by the time they get it into the data center and DR approved and all of those good things. So those all play into that agile space. You have services that have the 99.95% SLA for the compute resources, your website's load balanced, and as long as you're designing your application within one data center, within one hosted service with a few servers, you can run those services very availably. If you want to scale that out, run your service in multiple data centers and use services like Traffic Manager to load balance between the two. Those are services that are available, and it's about configuration, not developing and designing all of that infrastructure at that low granular level. We want to know that there's reliability built into the platform. The things we were talking about this morning about geo-replication of storage. It's a check in a box to make sure that actually all the things that we commit to storage are also stored in a secondary data center for our disaster recovery strategy. Something that a startup normally wouldn't get involved in until they were further down the road. That kind of comfort and knowledge that the system's not just going to vanish off the face of the earth one day. So the services that Azure offers that sit underneath this, we have cloud services, a kind of platform as a service model into which as a .NET or a Java developer or a PHP developer, you package up your application and you deploy it into those cloud services. That serves up either web pages or compute resource on demand and enables us, in the case of DrillBoard, to serve up a Silverlight app with all the web services that sit behind it, provide mobile APIs that then surface that same data out to iPad apps, to Windows 8 apps, to mobile phone apps, and enable the social sharing aspects by providing a storage place where we can store, for example, thumbnails of published images, and a really simple, quick way to serve those images up to consumers without putting load on our own web servers. We have the storage components, and there are a few storage abstractions. I won't go into too much detail, having had a great conversation this morning about how some of those work, but effectively 3 different ways to store up content, up to 100 terabytes, a limit that until this morning I thought was plenty. And that storage system enables us to reliably store information that as a developer all we have to care about is the REST API we call. We know that actually when we get the response back from that REST API, the data is secure and we can kind of fire and forget. We have media delivery. As the application starts to reach users in more and more geographies, the ability to tick a box and enable a content delivery network to locally cache images within a local country is something that's typically the preserve of a huge investment in an Akamai environment or a huge kind of data center investment. We have integration tools like Service Bus, areas where that cloud to on-premise bridge enables us to link transactions that are happening on our website directly into an accounting system that's sat nice and securely behind the firewall. We can bridge that gap without getting IT directors all upset and it having to enable inbound firewall ports or custom VPNs. We can build a service that sits on-premise and talks to our accounting system, and using the Service Bus, expose services that our applications can consume to push data into internal systems. In this case, every time a transaction happens where someone buys something or a card is rejected, it's fed into an on-premise accounting system to keep track of that. We have worker roles to process the secure background payments. In this case, we use PayPal as the integration provider behind this. For recurring payments, PayPal want to be able to kind of fire and forget we took money from your customer, here's the details. So we need a site that we know is up and listening, waiting for that message from PayPal, and then a asynchronous process with the worker process in the background to pick that message up, process it, and make sure that we're updating the customer subscription to say, well, they've paid an extra month, update the end date on their subscription records. So all of those tools within Windows Azure present effectively some of the things that we looked at when trying to consider what would a social application do and how would it work on Windows Azure. One of the interesting things that we found as a consultancy working with lots of developers from ISVs and with people who are from more of a business background and they don't really care what's going on behind the scenes is that actually you need to think ever so slightly differently when looking at the cloud. One typical scenario that we've seen a lot of within traditional ISVs is this model of put everything in the database. Put images in the database, put files in the database, put relational data in the database. Effectively, stuff everything into the database, which presents a bit of a challenge for the database. The relational data goes in, great, that's what it's really good for. Think about actually the database engine is a really tuned place to run optimized queries, to join things, to take that really normalized data, do some calculation, do some aggregation, do some joins. But actually what we find with a lot of applications traditionally developed is that all this other stuff is sat in the database as well. And the database is starting to bloat. And the first thing that a lot of ISVs have talked to us about when we want to move an application to Azure is, 150 gigs of database. How are we going to get past that? That's a limitation. And actually, when we sit down with a lot of them, we find that there's 2 or 3 gigs of relational data that actually needs to be in that transactional database, and then 50 gigs of images and 50 gigs of video and all sorts of non-structured content, but it's living in the database because it was an easy place to do it. The interesting thing is that even on-premise, that's quite an expensive way to do it. Your database has to sit on a server that's got a SQL Server license. It typically has to sit on some very expensive SAN storage. It's got to be clustered and run in a really scaled-out way. So thinking a little bit differently as you move an application to the cloud, you can look at the services that are available, the different types of storage that are available, and pick the one that fits best for what you need it to do. If you're serving up images, you're serving up blobs, actually there's a really nice way to lift those blobs, store them in blob storage instead of the database, and not only do you reduce the size of the database, but you reduce the load on your web servers. If you think about your application right now, when someone comes in, they make a request, that hits your web server. The web server's sitting there churning away, it makes a query to the database server. That database server is busy, there's open ports, there's threads dealing with that request. While you pull that blob, that image out of the database, you transport it across your internal network, you process it through IIS, and you fire it out to the client. There's a load of load throughout your infrastructure just to serve up an image. With blob storage, by moving that load onto blob storage, all you have to do is generate a shared access signature, a temporary license to get this private file, and you point the browser to that URL instead. And the Azure infrastructure takes care of serving that up. You've not got ports and threads being used. There's no load on your web server. Your web server serves up the HTML and forgets about the rest, lets the images and everything else be taken care of by storage. And that little bit of thinking differently can significantly reduce not only the load on your servers, but the cost of running the application. And that's really one of the things that we've uncovered with a lot of the ISVs we're working with, is that developers are focused on solving those technical problems. The challenge that comes in this new world is actually designing and architecting for cost. How do we design things in a sensible way that makes the most effective use of the platform at a cost and a price that works? And also, at the same time, doing so in a way that scales. So the services that are available within the platform, and I won't go into depth on huge volumes of them, but there's the relational database, and I probably will get the name wrong, I'll call it SQL Azure, but Windows Azure SQL database. Effectively, a relational database, cut-down version of SQL Server. It gives you all of the main features that you need in a relational database, with the notable exception right now of full-text indexing. But you can do your standard tables. Most databases we found with ISVs move pretty seamlessly into SQL Azure. We've migrated MySQL databases into it, SQL Azure, SQL Server databases, rafts of ISV applications. You can just lift and shift most databases into the cloud. Whether you should is an entirely different question. And the way to think about it is actually, does this data need that compute capability that comes with SQL Azure? Do I need to actually aggregate these numbers as I pull them out? Do I need to join them? And the answer, if you don't, is often to look at the alternative storage abstractions like table storage and blob storage. If we're storing data that we regularly get but doesn't change very often, actually blob storage can be a really nice answer. Structure the data in the way that the client wants to get it and just pull it straight out. The storage abstractions that are there enable you to think that little bit differently when delivering those applications. And the most important aspect of that we've seen is to build applications that spread the load, to focus on scaling the application out, not scaling it up. The traditional IT model of build a robust server and put more power supplies on it, put more redundant disks, get this mammoth great big server that becomes a bit like a mainframe with the intention that it never ever falls over, is starting to ebb and flow. Instead of doing that, why not have lots of commodity pieces of hardware that run your application and design for failure? Actually, if one of those nodes goes offline, so what? The platform will provision a new one for me. Design your applications to be stateless wherever possible. If you're going to run an application that spans across hundreds of servers, if you can avoid it, things like session state will really cause you problems in that scalable zone. Often, we've had real long debates with clients who say, well, but session state, we absolutely must have that. But when you boil down what you're doing with that, you can really minimize the amount of statefulness that you have within your application and apply it only where absolutely necessary. This concept of provisioning extra tin, if we've got lots of small bits of hardware, provisioning one or two extra ones of those is much easier than bringing online another hulking great rack full of traditional server and SAN. The ability to scale that application up and down when we don't need it is part of what makes these applications quite special when running them in the cloud. And in doing those things, by designing those things up front, you can start to remove some of the glass ceilings that exist for traditional scaling apps. As a very quick example of how some of this works, and that slide's not animated particularly smoothly, when you deploy your application, you take that service package and put it into the cloud. What Azure is then doing for you is all of the IT meddling under the hood that you would normally then do. So it's going to provision virtual machines that run your service package. I see Planky smiling. I suspect he recognizes some of these slides that have been fairly blatantly plagiarized. And it provisions the virtual machines that you need to run your infrastructure. It takes that service package within the Azure data center and deploys it onto the machines that you require. It's managing where those machines are and making sure that they're not all on the same network switch. They're not all on the same power supply. They're not all on the same backbone of the network. The system then brings a load balancer on board so that when your apps communicate with that, it's spreading that load equally across all of the instances running your application. And in the event of failure, which could be some kind of code issue that causes the machine to crash, it could be a machine going down for patching, it could be a hardware failure because they are commodity bits of kit. When that machine goes down, you don't necessarily have to intervene to do anything. The fabric is automatically going to provision a new virtual machine, put your service application into it, and update the load balancer to use that machine instead. And a lot of what I personally see Azure as is an operating system at the data center level. An operating system on a single computer is in charge of governing the resources that are available for you to use: storage, compute, memory. And as an application starts up, it asks for some resources. The operating system governs the resources available and makes them available to you. Windows Azure is simply an operating system at the data center level. It provides the compute resources, the storage, and the network and the communication within and across that huge estate of infrastructure that you can use. And what it's doing is managing all that for you. You don't worry particularly about what Windows is doing when you say, give me another 500 megs of RAM to load some process up. You let the operating system deal with that. What we're doing here is scaling that out to the data center and saying, I want an extra 5, 10, 50 servers to run my application, and it's up to the service and to the fabric to deliver those services for you to consume. So Azure fits really nicely then where applications need that massive scale. We've seen that this morning, but it also fits nicely where you've got a requirement for reliability and you might want to scale. It doesn't have to be the biggest application in the world to make use of Azure. But if you think we're going to launch Twitter today, it could just be the 50 of us in this room using it and we send a handful of messages a day. Or we might have Stephen Fry come on board and get millions of people following us. How much tin do we buy? How many servers do we buy? And the only answer I can think of is none. Let the platform manage it for you. On day one, we run it on a couple of tiny little instances, and our service is up and running in minutes. As millions of users come on board and scale out, that's when we start to ramp up the tin, and the glass ceiling isn't there. You might have to make a phone call to Microsoft to say, actually, I really do want to provision more instances, more service accounts. I don't want my credit card accidentally billed for half of Liberia's national deficit. But those settings are there to protect you as you sign the account up. They're there and readily available to be turned off. Apps that enable the communication between organizations, apps that want scalability, apps that need that reliability, all have a really nice fit with Windows Azure. And we've seen that in the diversity of the clients we're working with. So from the one-man band kind of football training guys who've bought a piece of technology and are building a business with some funding around it, through to working with national retailers. The interesting thing is that everyone sees a different angle for what you can use Azure for. The bit that's important is almost everyone can see some scenario where it works. And that hybrid technology of working some things on-premise, working some things in the cloud, and integrating them with services like Service Bus has been really powerful for us and for our clients of Azure. Some of the next steps, obviously, lots of exciting conversations today. I'm here until around lunchtime, so grill me, come back and ask questions. You can also follow on with the 6 steps of Azure. There are more and more sessions diving deeper and deeper into this. And if there's specific challenges you're looking for help with, I'm sure myself and any of the presenters here will be happy to chat through how some of those work in the real world. And we look forward to helping any of you really understand the platform and the opportunity it presents for your business and for your idea, to plan, design, and execute your app, how you're going to do it, how you're going to migrate something or come up with a new idea, and to make a great success of your Windows Azure opportunity.